Hi everyone, and welcome back to my series on CSEC Add Math Paper 2 solutions. So we're on June 2023 question 3 part B, which has to do with vectors. The position vectors of 2 points A and B relative to an origin O are such that OA equals 3i minus j and OB equals 5i minus 4j. Determine part 1, the unit vector AB for 3 marks. So before we determine the unit vector in the direction of AB, first we need to find vector AB. And vector AB is a displacement vector, where B is the endpoint and A is the starting point. So to find a displacement vector, it will be the endpoint minus the starting point. So therefore, it will be OB minus OA. So OB is 5i minus 4j, and we're subtracting OA, which is 3i minus j. So you just need to be careful with our signs when we're subtracting. So 5i minus 4j, and this will be minus 3i, and then 2 minuses gives a plus, so we get plus j. So 5i minus 3i is 2i, and minus 4j plus j is minus 3j. Okay, so now that we have vector AB, I can find the magnitude of AB, which will be the square root of 2 squared plus negative 3 squared. So that will be the square root of 4 plus 9, which is root 13. So therefore, the unit vector in the direction of AB is 1 over the determinant multiplied by vector AB. So our unit vector is 1 over root 13 times 2i minus 3j. So let's go on to part 2. Part 2 for 3 marks. The acute angle AOB in degrees to 1 decimal place. So angle AOB lies between OB and OA. So if this is O, this is A, and this is B, right, and these are vectors OA and OB, then the angle AOB is this angle here, which I'm going to label as theta. So first we need to find the dot product of the two vectors. So dot product of OA and OB, we just have to multiply the coefficients of I and J. So if you go back up to the top, coefficients of I would be 3 and 5, and the coefficients of j will be minus 1 and minus 4. So you multiply the coefficients of I together and then add that to the product of the coefficients of j. Alright, so the dot product will be 3 times 5 plus negative 1 by negative 4. So that's 15 plus 4, which is equal to 19. Okay. The next step is to find the magnitude of vector OA. So that will be the square root of 3 squared plus negative 1 squared, which is the square root of 9 plus 1, which is root 10. And then we find the magnitude of vector OB. So that will be the square root of 5 squared plus negative 4 squared. So that's the square root of 25 plus 16, which gives root 41. So therefore, cosine of our angle theta will be the dot product, which is 19, divided by the product of the magnitudes of the two vectors. So you divide them by root 10 by root 41. So on your calculator, that will give you 0.938. So therefore, theta will be cosine inverse of 0.938. And using your calculator to one decimal place, it will work out to be 20.3 degrees.